Alright, more arcs and chords. Theorem 10.3 states that if a diameter or radius of a circle is perpendicular to a chord, now the symbol for perpendicular is right here. It's the upside down T. If a diameter or radius of a circle is perpendicular to a chord, then it bisects the chord and its arc. And one other theorem to write down. Theorem 10.4. The perpendicular bisector of a chord is a diameter or radius of a circle. Okay, so those are two new rules for the rest of this section. And let's hit one more. Let's get Rule 10.5 or Theorem 10.5 written down, and then we'll do some example problems. And Theorem 10.5 says that in the same circle, or congruent circles, here's your symbol for congruent. Two chords are congruent. Two chords are congruent if they are equidistant from the center. And equidistant means equal distance. Equidistant means equal distance. Alright, so let's do a couple of examples. Draw a circle on your paper. And then put a center in the circle. And then a line through the center. That would represent a diameter. And then a chord. And draw your chord so that it's perpendicular to that diameter, which means that it intersects it at 90 degrees. And then we can label everything. We'll go M, J, let's see, JQK. So this is going to be JQK. And the other end of this diameter is L, and the center of the circle is Q. Oh wait, I'm sorry, the center of the circle is P. Now, given is that J to K equals 10. The measure of arc JLK, arc JLK, is equal to 140. M to P is 7. And you got to find the measure of JL. And you've got to find PQ. P to Q. Alright, so take the given information and get it filled into your picture, please. J to K is 10. Alright, J, from J over to K, that's 10 units. Arc JLK. Alright, arc JLK, from J through L over to K, that arc is 140 degrees. The entire arc, this entire red arc. $140 degrees. You need arc JL, J to L. Alright, you need this blue portion right here from J to L. Well, you just wrote down a rule that said if a diameter is perpendicular to a chord, then it bisects the chord and its arc. It bisects the chord and its arc. So you've got a diameter, M to L, that's perpendicular to a chord, JK. Since they're perpendicular, then the diameter bisects this chord. So this piece of the chord is the same as this piece of the chord. So each piece of the chord is half of 10, which is 5. So that piece is 5 and this piece is 5. Alright? Now the rule says that it bisects the chord and its arc. Okay? It bisects the chord and its arc. So if this entire arc is 140, from J to K is 140, then from J to L is half of that entire arc. So J to L would be 70 degrees. Got that? Now, this is a little bit complicated, but you've done it before. And this question is on the quiz. The next question is to find P to Q, which is this piece right here. Okay? Now, in order to solve this problem, here's what you're going to do. You're going to take, do you see this right angle right here? If you connect P to K, you form a right triangle, don't you? Okay? Now, do you see the distance from M to P? From M to P is 7 units, isn't it? If it's 7 units from M to P, how far is it from K to P? Aren't those both radiuses? Those both represent the radius. So this is 7 as well. So now, you got this little triangle right over here. I'm going to pull it out and I'm going to draw it right here. You got this triangle. You got P, K, Q. It's a right triangle. Q to K is 5 units. P to K is 7 units. And they're asking you to find P to Q, which is this piece right here. Okay? So in a right triangle, if you've got 2 of the sides and you need a third side, you can use the Pythagorean Theorem. So your a squared plus b squared equals c squared. So to find P to Q, alright, you got 5 squared plus P to Q squared equals 7 squared. So you get 25 plus PQ squared equals 49. If you subtract 25 from each side, then PQ squared equals 49 minus 25 is 24. And if you find the square root of each of these, then PQ equals, it's going to be the square root of 24. So in your calculator, .899, so we're going to go with 4.9. So P to Q is 4.9. Okay? Does everybody see how to do that? Alright, in order to find the third side, or in order to find P to Q, you've got to add this line, or this segment, or this radius to form this right triangle. And once you form that right triangle, you can use the Pythagorean Theorem to find the missing segment. Does that make sense? Alright, good. That covers the example, that covers the first 2 theorems that you wrote down in your notes today. So let's do an example that covers that 3rd theorem. And you're going to need another circle on your paper. And then once you got your circle, you're going to try to get, put a center, try to get a point right in the middle of that circle. And then you need a chord on the left and a chord on the right. And then from the center, you're going to put a segment to each chord. And you're going to make those 90 degrees. And now we got HRG. The center of this circle is J. Got KSL. Each of these segments from the center to the chord are 7 units. You're told that G to H equals 11. K to L equals 2x plus 1. And you're asked to find x. Okay, so look, this information that you're given, this G to H is 11. That's this chord right here. Alright, G to H is 11. K to L, that's this chord over on the right, is 2x plus 1. And you need to find the value of x. So you're given a bunch of information here. And the theorem that you wrote down a minute ago said in the same circle, two chords are congruent if and only if they are equidistant from the center. Well, since both of these chords are 7 units from the center, chord HG is 7 units from the center. LK is 7 units from the center. If the chords are the same distance from the center, then they're congruent. All right? So 11 is equal to 2x plus 1. The length of the chords are equal. So if you subtract 1 from each side, then 10 is equal to 2x. And if you divide both sides by 2, then 5 is equal to x. Now, the same will also be true if the chords are equal to each other. If the two chords are equal to each other, if you're told they're equal to each other, then you know that they're going to be the same distance from the center. Okay? So look, if you were to get, just look at this, it's going to be real fast. If you get this picture, and it's got a chord here, and a center, and it's got another chord over here, and this chord's 12, and this chord's 12, and you get this, and this is x, and this is 9. What's x equal to? 9, right? All right, if the chords are the same, then they are the same distance from the center. If the chords are the same distance from the center, then they're equal to each other. All right? The theorem is true and the converse of the theorem is true. If the chords are the same distance from the center, then the chords are equal. If the chords are congruent, then they're the same distance from the center. Okay? All right, and then one more thing I want to cover that we didn't talk about yesterday. Given a circle, put a center in that circle. And then split this circle up to look like this, please. 3 central angles. So if this central angle is x degrees, and this central angle is 119 degrees, and this central angle is 130 degrees, the sum of the central angles of a circle is 360, isn't it? The central angles of a circle sum 360. So if you take 360 and you subtract 119 and you subtract 130, okay, then x equals that difference. So let's take 360 and subtract 119 and then subtract 130. We get 111. We get 111 degrees. Okay? 3 theorems today, 1 review. Anybody got any questions? All right, your assignment for today. On page 718. You got 4 and 5. I'm sorry, 4 through 6. On 718, you got 4 through 6. And then 16 through 19. And then over on page 722, you can just keep flipping through. You're going to do problems 44 through 46. Okay? And I'm going to tell you to show all your work. You guys that are turning in assignments and all you're doing is writing down answers, or you're doing the work for half the problems and then you're writing down the answers as we go over in my class. You're not getting any credit this 9 weeks. Does everybody understand that? I don't give you that much work to do. This is 9 homework problems. And you've got 20-something minutes till the bell rings. So the expectation is that all the work's going to get finished and you're going to show all your work. If not, you're not getting any credit. Everybody understand that? Very good.